Hey there everybody, in this video we're going to be starting to graph sine and cosine functions. Now when we graph them for today, we'll be graphing them using radian angle measures. It is possible to graph these using degree measures, but today we're going to be sticking with radians. Now typically the hardest part people will have is dealing with fractions along the way, and that'll make sense when we get there. But for the most part, this should be a pretty straightforward pattern. And just like with graphing all functions, we're going to find patterns to kind of shift things up and down and left and right. All right, so first and foremost, let's go ahead, let's take a look at a sine function. So if I said y equals sine of x, where x is some angle measure, we would have called this theta. I can figure out sine of 0, sine of pi halves, so that'd be 90 degrees. Sine of pi, that's 180. Sine of 3 pi over 2, that's 270. And sine of 2 pi, which is a full 360. You'll notice I really only need to go up to 360 because after it, it's just going to start over again. Because after we go 360 degrees around, we kind of do a full lap around the circle. Here I've got my unit circle. If I'm thinking sine function, all of these coordinates give me cosine, comma sine for every single one. So the cosine value is first, the sine value is second. So the sine value at 0 is 0. Sine value at 90, or pi halves, is 1. The sine value at pi, or 180, is 0. At 270, or 3 pi halves, is negative 1. And then we're back to 0. So it goes 0, 1, 0, negative 1, 0. Those are the values that we are going to achieve. So I'm going to go ahead and mark that out. 0, 1, 0, negative 1, 0. Graphically, if I wanted to set this up, I could label my axis. I'll start with the y. Midline is 0. Amplitude would just be going up 1 and down 1. And then I need to label out my x-axis. Now here's the way I like to do it. I first find the period of the function, and the period is how long does it take for things to repeat. For this one, that would be 2 pi. So I'm going to go ahead and figure out the period of that function, which is 2 pi. And then from there, what I do is I'll chop that in half, so right here, and then I'll chop each half in half. Now to figure out how many steps I'm taking to get out there, what I like to do is take this period value, in this case 2 pi, and then I'm going to divide that by 4. When I do that, I get pi half, pi over 2. Now, the reason why I say this is we're going to see down the road it come in handy, but that's going to tell me how to count up these increments. I'll have 1 pi over 2, 2 pi over 2, 3 pi over 2. So 1 pi over 2, 2 pi over 2, 3 pi over 2. And if we're lucky, like right here, some of these might simplify, right? 2 pi over 2, well, that's just plain old pi. That's just plain old pi. All right, so now what I need to do is go ahead and graph these values on this function. I'm going to sketch in some dotted lines just to give myself a little bit of framework here. And my graph is going to start off at 0, 0. And then at pi halves, we go up to 1. At pi, we go back down to 0. 3 pi over 2, we're down to negative 1. And at 2 pi, we're back to 1. So I will do my darndest to connect the dots with a sine curve. Not the best, but you get the idea. So that is the general shape of a sine graph function. Important things to note moving forward is that sine will start off at 0, 0. And then it oscillates max to min back to 0. Let's take a look at cosine. So cosine is going to be the first numbers in these parentheses chunked. So we go 1, 0. Back there would be negative 1, 0, 1. So 1, 0, negative 1, 0, 1. The setup for this one is going to look the exact same as the sine function. The only difference is the shape of the graph. So I'm going to go ahead and set up my axes pretty much the exact same way. So we have 1, 0, negative 1. Then we had 2 pi, and we counted up by pi over half. So 1 pi over 2, 2 pi over 2, 3 pi over 2. We'll sketch in our little boundary lines. In this function, we are starting off when my angle measure is 0, my function value is 1. At pi halves, we're back down to 0. Then we go down to negative 1, back to 0, up to 1. Now we can't just make a nice little V shape like that. It has to be a nice kind of smooth curve. So when I sketch in my graph here, it's going to be a nice smooth curve. And it should be done in such a way that I should be able to kind of copy paste that and it would continue on over indefinitely. The domain for both sine and cosine functions is going to be negative to positive infinity. Your range is going to be between negative and positive 1. The domain will always be negative to positive infinity. It will always be all real numbers. The range will change if we change the amplitude of these functions. Remember, the amplitude is how far away from the midline we go to hit the max or to hit the min. All right, so here is a general shape of what each one looks like. The sine function is here in red. So sine starts off at the origin, swoops up, swoops down, and ends back at the x-axis. The cosine starts off at the top, swoops down to the min, back to the top. You'll notice they kind of have the same pattern. It almost looks like a DNA double helix. And the reason for that is that these are technically the same graph. The sine function is just pi halves ahead of the cosine function. So they're just kind of offset by 1. And the reason for that, you can kind of see in the unit circle, is if I look at these values for sine and cosine, and if I kind of jump one quadrant ahead, you'll notice these values repeat over and over. So for instance, here I see rad 3 over 2 as a cosine value, but later on it shows up as a sine value. Conversely, I see 1/2 showing up as a sine value. Later on that shows up as a cosine value. So they all go through those same angle measures and the same cosine and sine ratios. They just kind of show up at different spots. All right. Take a picture of this screen, please, folks. Now we're going to start moving and changing and transforming these functions. So we know the basic shape. Sine shapes kind of sort of look like an S. Cosines kind of sort of look like a C, but not really. But now we're going to start stretching them vertically, aka changing the amplitude. We're not going to mess around with the midline yet, but we will make them taller. We'll make the peaks higher and the valleys lower. Then we're also going to change the period of the function, and that's basically a horizontal compression or stretch. So the b value is going to tell us how many cycles do we go through within the span of 2 pi. So what that means is if b is 3, we go through 3 cycles within the span of 2 pi. So we're going to have a graph that looks much more condensed, specifically 3 times more condensed. The way we can figure out our new period of the function is we take 2 pi and we divide out b. So if I think of 2 pi as being 360 degrees, let's pretend our b value is 3. That means our function repeats itself 3 times in the span of 360 degrees. So each cycle that it goes through would be 120 degrees. That's where that's coming from. But if we're speaking radians, instead of 360, we use 2 pi. It says the same thing, speaks different language. All right, let's take a look. We want to identify the amplitude and the period of the following functions. So the amplitude and the period for the following functions. So the amplitude is going to be the coefficient in front of the word sine or cosine. The amplitude is always going to be a positive number. If there's a negative sign out front, that just means our graph got flipped upside down. That does not mean we have a negative amplitude. Our period, I'm going to call that P. Our period, remember, is always 2 pi divided by our b value. So the number in front of the x doesn't necessarily tell us the period, but it helps us find it. So we'd have 2 pi divided by 1, or just 2 pi. Number 2, we'd have 2 pi divided by 3. I can't really simplify that. For number 3, you'd have 2 pi, oopsies, 2 pi divided by 2, so that's pi. Fractions. Let's tackle some fractions here. Number 4, amplitude would be 1/3. Our period would be 2 pi divided by pi. Well, that's just 2. Number 5, our amplitude, there's technically a 1 chilling there, is a 1. Our period would be 2 pi divided by 1/3. Well, how in God's green earth are we going to do that? Well, here's how this works. Some of you may remember from dividing fractions way, way long ago. If I have 2 pi divided by 1/3, that's the same as me saying 2 pi times 3/1. If you ever need to divide out a fraction, just multiply by the reciprocal of that second one. So this would be 6 pi. Number 6, our amplitude here would be 5. Our period would be 2 pi divided by 4/3, which is 2 pi times 3/4. Well, 2 pi times 3 is 6 pi all over 4. 6/4, that can reduce. That's going to turn into 3 pi over 2. Let's get to graphing. So, to graph a sine or cosine function, first we'll identify the amplitude and period. We just did that. And then we need to figure out the intervals for the x-axis. The way we do that, and I mentioned this earlier, is we're going to mark the period at the end of our x-axis that we have drawn out, and then we're going to chop it in half, and then we'll chop each half in half. To figure out these little tick marks, we need 1/4 of that period. So that's why it says here, multiply the period by 1/4 or divide it by 4. These are saying equivalent statements. Multiplying by 1/4 is the same as dividing by 4. Then we'll plot our points and connect the dots with a smooth curve. All right, let's get to stepping here. We want to graph one period of the function, clearly label both axes, and plot some points. Okay, our amplitude is going to be 3. Our period is going to be 2 pi divided by 2, which means our period is going to be pi. So that goes over here at the end. Now, our intervals, if we're setting up our little tick marks here, we'll chop our first length here in half and then chop each half in half. To figure out these intervals, all we have to do is take our period value and divide that by 4, or multiply it by 1/4. It's the same thing. So our intervals, in this case, are going to be pi over 4. That's going to be what we're counting up by. So I'll have 1 pi over 4, 2 pi over 4, 3 pi over 4, and 4 pi over 4. Now, some of these will reduce, right? 2 pi over 4, that's really 1/2, pi over 2. 4 pi over 4, well, that's just plain old pi, so that kind of works out. So 2 pi over 4, I'm going to go ahead and call that pi over 2. All right. My amplitude was 3, so that means from the midline, I'm going to go up 3 to positive 3 and down 3 to negative 3. We'll draw in our boundary lines, and we'll get graphing. I've got a sine function. Well, the sine function starts at the midline, goes up to the top, down to the bottom, and then back to the midline. So I need to apply this shape to this setup. Well, if I start on the midline, I'll end on the midline. From there, I go up to the top. So the next step out, I'm going to be back up to the top. And then it looks like we come back down through the middle and down to the bottom. So back down through the middle and then to the bottom. And there's my 5 points. To the best of my ability, I'll connect with a straight line. Or not a straight line, a nice curve for the sine graph. All right, next up, cosine of 1/2 x. Amplitude is 1. So that means I go up 1, I go down 1. The period comes from the b value. So we'll have 2 pi divided by 1/2. Well, that's the same as 2 pi times 2 over 1. That's going to be 4 pi. So our period is 4 pi. The interval is going to be 4 pi divided by 4. Well, that's just 1 pi. So we'll count up 1 pi, 2 pi, 3 pi, and of course 4 pi. And now we graph. I'm going to sketch in my little boundaries here, just for reference. A cosine function starts at the top, swoops down to the bottom, and then ends back at the top. So we'll start on the top line, we'll end on the top line. Then we swoop down through the middle, all the way down to the bottom, back up through the middle, ending to the top. And we'll connect those dots with a nice smooth curve, no sharp corners. There we go. In the interest of time, we've got a few more. I'm going to do just 2 of these. We don't need to do all of them. So let's do number 4. Yeah, we'll do numbers 4 and 5. Yeah, no, we'll do 3 and 5. We'll do numbers 3 and 5. Or maybe 5 and 6. I'm all over the place, people. Yeah, we'll do 5 and 6. They're next to each other. Why not? YOLO, right? Okay. So number 5, we have 2 cosine 1/3 x. So our amplitude is 2. Don't have to do much thinking there. The period comes from this b value. So to figure out the period, I do 2 pi divided by 1/3. That's the same as saying 2 pi times 3 over 1, which is 6 pi. So I'm going to end at 6 pi. Then to find the interval, I take the period, which was 6 pi, and I'm going to divide that by 4. Well, that's going to be 3 pi over 2. So the intervals in which I'm counting up will count by 3 pi over 2. So I'll go 3 pi over 2, and then 6 pi over 2, and then 9 pi over 2. So basically those numerators are counting up by 3s. I'm taking 3 pi's. So 3 pi over 2, 6 pi over 2, 9 pi over 2, and 12 pi over 2. Now, if we can reduce any of these, we will. 3 halves, that does not reduce. 6 pi over 2, oop, that's a 3 pi, so I can reduce that down. That'll be 3 pi. 9 pi over 2 does not reduce. And then 12 pi over 2, well, yeah, we already knew that was 6 pi. All right, hard part's over. Let's start graphing this. We've got a cosine shape, which means it starts at the top line, goes down through the middle. So it'll start at the top, goes down through the middle, hits the bottom, back up through the middle, and ends at the same line it started on, back at the top. So it starts at the top, goes down through the middle, all the way to the bottom, back up through the middle, ends where it started. Connect your dots, and we're done. So this is what I was saying at the very start of the video. The hard part with problems like this is dealing with fractions. All right, one last one, then we'll call it a day. We'll call it a video. Y equals sine of 6x. There's no a value given, so I can assume it's a 1, which is my amplitude. That allows me to sketch out my max and mins. And then my b value here is 6, and that's going to lead into finding the period here. So 2 pi over 6. Well, that's pi over 3, pi thirds. So my period is going to be pi over 3. To find the interval now, I need to do pi over 3 divided by 4. Now, some of you might be wondering, how on earth are we going to do that? Well, you might remember, think back, way back, we can divide by 4 or multiply by its reciprocal 1/4. That might be easier here. Let's multiply by 1/4 since we're dealing with a fraction. So instead of pi over 3 divided by 4, I'm going to think of this as pi over 3 times 1/4, which gives me 1 pi over 12. So my denominator is going to be 12, and I'm counting up by 1 pi. So it'll be 1 pi over 12, 2 pi over 12, 3 pi over 12. So 1 pi over 12, 2 pi over 12, 3 pi over 12, and 4 pi over 12. Let's see if we can reduce. 1 over 12? Nah. 2 over 12, yep, that would be 1 over 6. So this would be pi over 6. Uh, 3 over 12, ooh, that can also reduce. 3 over 12, that would be pi over 4. That would be 1/4. And then 4 over 12, well, we already know that that's going to be 1/3. We already have that written out. All right, so we should be good. What kind of function were we dealing with here? So we have a sine function. Sine functions, in case we forgot, start at the middle, swoop up, swoop down, back at the middle. So we're going to start on the midline, go to the top, back to the midline, to the bottom, back to the midline. So these are the 5 key points we've got to hit. And we'll draw a nice smooth curve. And we're done. All right, folks, that's it. That's all. You know the drill. If you have any questions, do not hesitate to ask. And as always, good luck, have fun, be safe, roll tide.